scrap, does that include the energy that Germany is currently buying from France? Because when they removed a lot of nuclear from their grid.
Actually, to be honest, I don't know in detail, but this data is based on their total energy, which they're receiving. But if they're receiving any energy in the renewable, of course, it could be the part of this, and it could be the part of this too. But in my opinion, I'm not sure this part, the German, I meet the one very big scientist in Germany at the conference. He said, we have a few politicians that they are creating trouble for us, and they still supporting, and behind them is some big industrial groups or something. But he say we hope to overcome soon. So it means that I don't think so they will import from France or any nuclear. Other is okay. Maybe they can, nuclear maybe no from France.
So you think that like petroleum and hard coal are better resources than nuclear for the world?
No.
Okay.
No, only renewable energy.
Okay.
And I hope you will also like it.
Yeah, I do, but like petroleum takes up 34%, hard coal is 12.2.
Yeah.
And like those are both either right around renewable or larger than, and like nuclear has
I will
no
show
carbon
one slide to
footprint.
you, one slide, which is, I don't know this scientist. He tested the data by simulation. If I have, I will quickly show that slide to you first. It's very relevant. Maybe Melissa already know, I talked about this part in Iceland. Yeah, this part. So we should not be disappointed. We should be optimistic. Why? According to the device, covering of 0.16% area on planet Earth, just 0.16%. With 10% efficient solar cell. If we have very low quality of solar cell, having 10% efficiency, not good solar cell, could possibly provide 20 terawatts of the power, which is sufficient enough for our yearly consumption of energy, of the whole planet Earth. So we just need little efforts to expand the solar energy and bring awareness. Later I will talk about one point that the silicon, this making silicon is the material for solar cell, and it is a little expensive. If the government in the financial institutions support them, and they make such a plan that the electricity which provided by a front company, which is based on that material, silicon material, front company, just to give electricity to the villages and towns, and then slowly recover the money in terms of monthly, and then the government make a financial system to make a very, very good checking, not to do any illegal things, and like in terms of money and all the things. I think it's one of the, in my opinion, is one of the good way to do it. But for that, we need, as I told you before, we need the interaction. The scientists, engineers, with energy managers, politicians, and all people have to interact. Then we can make a good plans for the sustainable or renewable energy.
The point I was just trying to make is, like, should we really be celebrating countries moving away from nuclear when they're not filling that infrastructure with renewables yet? They're filling it with carbon sources. So like, I was just making the point, like keeping nuclear to fill the gap until the renewable infrastructure is there is better than keeping the carbon.
In this case, the European, in 2014, the whole Europe, the renewable crossed the nuclear. Whole Europe. I will show it on my paper, and I mentioned that in my research article. And it's for the first time. And maybe that's a question I should go quickly to that paper. I think I put here. Maybe it's very small. I don't know if you read. The year 2014 was said to be a benchmark for renewable energy in the Europe, with renewable producing more power than nuclear power for the first time.
Right.
Yeah. So it means the European has started. Europe is a key area. Now Japanese government is also thinking like this Fukushima problem, decommissioning, and they looking for some business partner to to sell out their garbages of the nuclear parts or machines. But in my opinion, that's some country would like to buy it, like Mexico or even Pakistan or some countries, some crazy countries would possibly buy it. But now Europe is okay, Japan is going to do that, and maybe in US, maybe I don't know too much about US, but maybe they have a strong opposition to the nuclear energy. No? Anyone can guide me today? How about in US? Nuclear energy is, you guys like or no?
I think it's better than fossil fuels. When you're decommissioning nuclear plants and filling the grid with fossil fuels rather than renewable, then that's a problem. Like, we shouldn't use fossil fuels to bridge the gap between nuclear. We should be using nuclear to bridge the gap between fossil fuels as the renewable technology develops.
You mean that we need certain transition time?
Yeah, because the infrastructure, to build up the infrastructure.
Right, it's a good idea. But in this case, I would say one comment that if the US want to continue, or any country, they have to revisit their plants, their condition of the plants. And they should devise some SOPs, standard operating procedures, and also some quality assurance and quality management things.
For nuclear?
Yes.
Yeah, their
Because-
manuals are taller than I am.
Yeah. So they know the thing which I know in Japan which happened. The tsunami is non-linear problem. We don't know. And sometimes our seismic activity we cannot predict. So if the plant foundation is on such place which cannot withstand with high Gs, with high seismic activity. So I read one paper last year with some people trying to make some flexible structure, some mechanical flexible structure to have a control system design, feedback control system if the earthquake, how to suppress the natural frequencies. You know the natural frequency which can destroy the building. So they thinking now this is one of the way to make more safe, but it's very expensive. You're adding more cost. But anyway, we have to move to renewable energy. Anyway. So, okay, these are the few. I think you guys receive a lot of information about the wind and solar, and I don't want to go into this detail. And you already know. But I don't know about hydrogen. Did someone talk to you about hydrogen? Oh, okay. This I would like to. This is very important. For me, this is not so. Hydrogen is of course volatile, or it can get fired very easily. But recently, Germany and American also, and Japanese, they made a very good catalytic process, chemical process to convert to another safe chemicals you can carry, you can handle. So what fundamentally you can do to produce hydrogen from this area, from the solar and wind, and store and convert to the safe, and then you can use for this kind of fuel cell vehicles, which is based on a fuel cell. This car, it's also a green car, I believe, and you can provide the electricity and smart houses by transportation of the hydrogen. Safe carrying hydrogen to the smart villages and towns. So this is one of the good ways. I heard from my professor in Tsukuba University, the Japanese government is trying to make a contract with Egypt. So they want to install a solar panel in the Arab Peninsula in Egypt, and then produce hydrogen and transport through the sea to Japan. And my professor is one of the supervisor to the Ministry of, what do you say in English?
Minister of Education.
Ministry of Education. And some other, they were looking at this project. So we in Japanese we call it Momokaraksho. So let me quickly go what I'm doing. This is the solar cell. From the sun, we're receiving all these radiations, this solar spectrum. And this is the wavelength of the light from 500 to 2000 nanometer. This is the sunlight having different wavelengths we receiving on Earth. So some people just using these parts, some people using these parts. So for this part is a very large wavelength. So you need also the band gap of the material should be bigger band gap. So I will talk about how to make solar cell devices. One of the area I will not talk about much more, but about this part. When I was a student in the University of Scuba, so we made a solar cell. This is the silicon. It's a new material, barium silicide. Barium and silicon together. And this part with the doping and type, and we make a solar cell. Efficiency is 1.6, very low. 1.6 is nothing. And then my group, we tried to change this layer with p-type. We changed this to n-type, this part. And this layer we changed the antimony, Sb is the antimony, the element. We use boron, B. So this is the same structure here. And we changed this layer to p-type. And this work is published here in the APL, Applied Physics Literature. You can download if somebody is interested in this. Here. So after making this layer and we make a solar cell, the efficiency goes to 11%, from 1.6 to 11%. Just little research. So I would recommend you, please, if those people who belongs to chemistry or physics, who wants to do material science research or device, you can contribute very easily. Just this is not rocket science. Just you have a machine and just mixing material and then checking, go back, see the electrical properties, efficiencies, and IV curves, current and voltage, and you're reading some books and papers, and you could be a very smart researcher. And you will be contributing to the solar cell. And this work, our work was published in Japanese newspaper. Oh, this is p-type. Our work was in the newspaper news. Tsukuba University discovered p-type, our group. And this is the paper, yeah, our paper of this discovery. And another thing which I'm talking about the solar cell. Sorry, can I help? No, okay. Just to conclude this part, okay? This is the, just for the example, this building glasses. So we made a solar cell. This is the Asahi glass, in Japanese made glass, and we made the silicon base, amorphous silicon base, heterojunction solar cell. And the efficiency was, this solar cell was about 10.7%. It's not bad. Last year it was the highest efficiency in the world. But now I don't know because I changed my area. So we need to polish some more things, and then it could be very good just to paint on the glasses and put on the building. But in this case, I would say that architecture engineer and civil engineer are very important to work with the solar research. So let's go to the conclusion. Okay. This part I would say. Promoting solar cell, wind energy, biomass, and geothermal through technical education and research collaboration via United Platform is the good way to. And replacing conventional lights, bulbs, and traffic lights with LEDs technologies. This is one of the ways we can reduce and also we can reduce the carbon dioxide emission. Using LEDs technologies for agriculture applications. We need to preserve water reservoir on planet Earth. This is also a very important point. We must try to preserve water. Revisiting the industrial setup to shift to the eco-friendly and green industry. We have to revisit all industries which we have for car, for food, for anything. Whether we are using safe and secure chemicals or not. So this is a very important point. Promoting communication among scientists, engineers, energy planners, politicians, judges, an energy investor for sustainability of renewable energy across the world. Not only small area, we have to work globally. Then we can do something. Civil engineers and architectural engineers are needed to work in a close collaboration with renewable energy engineers, scientists, experts, to promote energy efficient and smart building, smart highways, and smart homes. Government should give subsidy on renewable energy resources to the end users, the people who are using. This is one of the good ways to support by the government. And so, yeah, this is the last slide which we go with Melissa, and I hope you can see she's here. Melissa is here. So we have a nice time there, but I was a little sad about this glacier melting. I think everybody was sad. So, and last but not the least, I will show one very important piece. This is by American guy, and I like his theme. Climatic change could lead to the humanitarian crisis of epic proportion. We are already seeing migration of large number of people around the world because of food scarcity, water insecurity, and extreme weather. And this is said to become the new normal. Brigadier General Stephen Chen, U.S. Department of State, Foreign Affairs. It's very good words to say. I hope every American will follow him. That's what he said. So thank you very much for your kind attention. Sorry for some. Everybody all right? Yes. If you have some brief question, I think everybody may be hungry or it's all right.
Yeah, we can maybe take one question if you guys
Or
have
any,
questions. Okay.
Sources that born
Well,
yeah, from solar source, are they being used right now? Do you have any
no, it's just on the experimental stage, it's passing. It's a very new result, it's just in 2013 or 14. So I hope it will come, and this material is cheap. Not to put panel on the car. Okay, just you should have my email from this time.
Oh.
Feel free.
Oh, yeah.
Yes, yeah. Just.
Thank you so much, Dr. Khan. Guys, we are headed to the Solar Agriculture Park now, so lunch is on the bus ready for you, so we need to load up right away. Thank you.
I hope this